All right, moving into 7.4. This is a new packet. Okay. So the greatest common factor is what we're going to be dealing with today. So if we review, it says find the product. So we're just going to do two of these. We use this distributive property. M squared times 2m squared is 2m to the fourth. M squared times negative 3m is negative 3m cubed, because you're doing the m squared times m, is m cubed. Then m squared times 1 is just m. And then over here, we do this one, same thing. 3d to the 7th minus 15 from 3 times 5, and d to the 4th times d is d to the 5th. And then this last one we add 6 times 3 is 18, d to the 4th. And then I'm done with those. I don't turn around, and this is wrong, so don't do this, but I still have a few kids doing 2 minus 3, and they'll do negative 1, and then they'll do the m to the 4th, m to the 3rd, and m, and do something like that, and add them and subtract them and combine them all together. That's wrong. Please don't do that. So what we're going to do here with the greatest common factor, so the GCF is the largest number and variables. In this case, we're dealing with polynomial. A polynomial contains. The largest number and variables a polynomial contains. I'm going to skip the example part because we're just going to do 4 of them down here. So we really wanted to be specific on how we do these. What you have to do is you take this 8 and you break it down, and what we do is what's called the prime factorization. And I'm going to do that on the first one, and then I'm going to be done with it. So what you do is you take the 8x cubed, and then we got to break it down. Well, what does the 8 break down into? So we're going to find prime numbers that multiply to get 8. Well, I can just break this down into 4 times 2 initially, and then the 4, and then that's prime. And the 4 breaks down into 2 times 2. They're both prime. So then I end up with 2 times 2 times 2. Because if I did that, that gets me back to the 8. Now how do I break the x cubed down? Well, that's just simply x times x times x. If I combine those all together, x times x times x, I would get x cubed. Then I can do this again on the 24x squared. And actually, ignore the negative for now. We could break that down into 6 and 4 or 12 and 2, doesn't matter. So I can do 6 and 4 here. 3 and 2, there's prime number, there's a prime number. 2 and 2, also prime numbers. My x squared breaks down into x times x. So then if I was writing the prime factorization of this one, I would have 3 times 2 times 2 times 2 times x times x. And if I multiplied all that together, I'd get back to the 24x squared. And then last, I have the 16x, which I'll do 4 times 4, which just ends up 2 times 2, and 2 is a prime number. So for this one, I have 2 times 2 times 2 times 2, and then my x. So now we're looking at what do they have in common? Well, in this case, we have a 2, and a 2 in common on this one that it shares with these. Okay. So I have 3 2s that they all have in common. Well, how many x's do they have in common? You could just look back up here. And it's supported by the prime factorization, but obviously if this one has 1x, this one has 2 x's, and this one has 3, we could all agree that they have 1 x in common. So then I rewrite this as 2 times 2 times 2, well that's 8. And I have an x left. So what happens is that this 8 should divide into all of these. 8 goes into 8 one time, 8 goes into 24 3 times, and 8 goes into 16 2 times. And that's going to come into play later this week. You divide it out, and you're going to write what's left. So you could do all this garbage here, and hey, if it helps you, great. But here's how I like to do it. I start with the smallest number. So if I'm looking at number 6, I have a 5. Does 5 go into 15? Yes, it does. 5 times 3 is 15. Does 5 go into 30? Yes, it does. 5 times 6 is 30. So what's the biggest thing that these all have in common? Well, they all share the number 5. Now, about the c's, we have a c squared here, a c here, but we don't have a c here. So there's my answer on that one. They just share a 5. That's the only thing. So when we're doing the GCF, we're trying to find the largest number n variables that a polynomial contains. But if they don't all contain a variable, you can't pull that out in front. We're going to kind of have the same thing here on number 7. Because if I start with this number 3 here, does 3 go into 8? It doesn't. So I could break 3 down into smaller numbers, like up here, like 8. I could break that down if I needed to. Like, for example, if you had like 8, 12, and 16. It's kind of a little size piece here. If I had 8, 12, and 16, I'd start with 8. And yes, it goes into 16, but it doesn't go into 12. So you'd have to break 8 down into 4 and 2. But in this case, then, now that I've broke it down into 4 and 2, 4 goes into 8, 4 goes into 12, and 4 goes into 16. That's just another way to look at it, as opposed to doing all this work and writing out all these prime factorizations. So back to this 3. 3 does not go into 8, and 3 is a prime number. So the only thing that goes into all 3 of these numbers is a 1. And then I look at my f's. I have a 6, a 4, and a 2. Well, the smallest of those is that 2 right there. So what do they all have in common? These 3 terms share an f squared. Right? On number 8, start with my smallest number, 16. Does 16 go into 32? Yeah, it does. 16 times 2 is 32. So that's already what they have in common in terms of numbers. They both share 16, because again, we know that 16 times 2 is 32. What do they have in common for the variables? Well, I look at my 2 g's, I got a 4th and a 5th. So they both have at least 4 g's in common. And how many h's do they have in common? 2, because h squared here, h cubed there. So that's what they have in common, because again, remember, that would be h times h over here, h over here. So how many h's do we have in common? 2. Okay. So we're going to skip this page for today, and then go to this practice here. And there's 12 of them, but all you have to do is do the GCF. So like on number 1, this is a good example. 15 doesn't go into 27, but 5 times 3 is a factor, and 3 goes into 15 and a 27. So my answer on this first one is 3. On number 2, same thing. 6 does not go into 14, but if I take that 6 and I break it down into 3 times 2, 2 goes into 14, 2 goes into 6, so they both share a 2. And that would be a part of your prime factorization, because then over here, if I did this, my prime factorization is 7 and 2. And again, look, they both share a 2. How many W's do they have in common? Just 1. There's my answer for that one. And last one here, number 3 I'll do for you. And this one might be a little tricky, seems like at first. Because what are some factors of 63? What are some factors of 45? You got to start thinking those factors in your head, or you can do the prime factorization. What's the largest thing they have in common? Well, hopefully you notice that they both share a 9. Because 9 times 7, 63, and 9 times 5, that's 45. So what do they share in common? Well, they can't share an S because there's not an S over here, but they do share a 9. And just one more time, so you can stop the video if you want here, but I'm going to finish up number 3 here with a little more explanation. You're doing 1 through 12, for those of you that are still watching. How do I get this 9? Well, again, that prime factorization, so if I do 63, doesn't matter. I could do 21 and 3. There's a prime number. And then 21 breaks down into 7 and 3. There's my prime factorization for 63. 3 times 3 times 7. I'll take my 45 and I break it down. 15 and 3. 5 and 3. So my other prime factorization is 3, 3, and 5. So what do they have in common? 3, 3. 2 3s. Well, what's 3 times 3? 9. That's how I got to that answer. If using those factor trees help you. Prime factorization, going right back to 4th grade. This is what some of the 4th graders in my school are doing right now. Okay. That's it. Good luck and get these other 9 done and get them uploaded along with the notes from the first page.